Alright, so what I'm going to show you today is how to do the calculations for the worksheet and for the practice problems involving wavelength, frequency, and the speed of light. The formula we're going to use, C equals lambda times nu. C is the speed of all electromagnetic radiation, which has a value, it's a constant value, 3 times 10 to the 8th meters per second. Lambda, or the upside down Y looking thing, is the Greek letter L, and it stands for length. So that's why we use it for wavelength. Now typically the units for wavelength are meters. But we can also have different variations of meters, such as millimeters, centimeters, kilometers, whatever it is. We have to figure out a way to deal with that, and we'll get to that in a few minutes. The other one looks like a V carrying a little tray, is the lowercase Greek letter nu, which is the F in the Greek alphabet, and that stands for frequency. The units for frequency are called hertz, H-E-R-T-Z. And is abbreviated with a capital HZ, but hertz is also kind of a confusing name. Frequency represents how many waves are passing a point in a given amount of time, and that time is generally 1 second. So really the units are waves or anything per second. Since it can be anything per second, we just write it as 1 over a second, which we'd call a reciprocal second. So when we're doing the calculation, C equals lambda times nu, our lambda has the units of meters, our frequency has the units of reciprocal seconds, and so when we do the math, we end up getting meters per second. That's a velocity, or a speed set of units, meters per second, and that is the units that we find that go with C, our speed of all EMR. Now, as far as using these in calculations, we'll use example 1 from the worksheet to illustrate how we do this. Number 1 says, find the wavelengths that correspond to the following frequencies. So we need to find the lambda when we're given a specific frequency. And in number 1, it's 78, 74, and it's given there as PHZ. PHZ is a metric prefix version of hertz, and that is picohertz. If you look at the bottom of your page, pico has the numerical equivalent 1 times 10 to the negative 12th. Now the problem with our given frequency, we can't use picohertz. It won't work with the math. It'll be off by too many times. But we can put the value of P, or of pico, into this, and so our frequency then just becomes 7,874 times 10 to the negative 12th, and we've gotten rid of the pico, and now we're just in hertz. The pico is times 10 to the negative 12th, and so we just put it in place. And now we can do the calculation. C equals lambda times nu, and we're trying to find the lambda, which means we have to get it by itself. To do that, since it's multiplied by frequency, we have to divide by frequency. But we have to do it to the same, or to both sides, to maintain the equality. The frequencies then cancel, and we find that C divided by the frequency gives us the wavelength. We know the value for C, it's a constant. We're given the value, or we just found the value of frequency. And we're solving to get wavelength. Now what happens with the units? C has the units meters per second. Frequency has the units 1 per second. We have a per second in the top and we have a per second in the bottom, and those per seconds just cancel, leaving us with only meters. And that makes sense because wavelength should be a length unit, and meters are definitely a length unit. Now we're also dealing with numbers in scientific notation. And if you don't remember on your calculators, there are 3 buttons you typically should look for. These are the 2 most common, the EE button or the EXP button. There are a couple other versions, but I'll show you on my calculator. If you looked right above the 7, you see the big EE button, and that's the scientific notation button on here. And that's the one I'm going to have to use when I do the math. Now that scientific notation button takes the place of that, the times 10. We have to supply the power, but that's what the EE button is for. So you would type in for the very first value 3, and then the EE button, and just 8. If I show you on my calculator, 3, EE, and 8. And it comes up on the display like that. 3 and that little 08 means times 10 to the 8th power. Then you're going to divide, and we want to put 7,874, hit the EE button, and then the plus, minus, and 12. So going through and doing it on mine, which is actually kind of confusing, divided by 7,874 EE, and my plus minus is right here, and it shows up as 7,874 times 10 to the negative 12th equals button, and that's what I get, 3.81. Those extra decimals don't mean a whole lot, but the little 16 in the upper right hand corner means times 10 to the positive 16th value. And since we figured out earlier that our units are going to be meters, that would then be meters. Now, if we're going through and finding the wave or the frequency from the wavelength, it's pretty much the same kind of math. It's just the algebra solving for the different one. We're still using C equals lambda times nu, only now we want to solve for frequency, which means we have to divide both sides by lambda. So then C over lambda equals nu. Again, look for any powers of 10 that go with any prefixes, put them in the appropriate place, do the math, and the units should work out. When you're solving for frequency, your answer is going to have the units of just hertz. When you're solving for wavelength, your answer is going to have the units of just meters, like we saw in problem 1. Any other questions? You know how to find me. Have fun with this.